Today we'll be looking at vectors in one dimension. Tomorrow during your at-home day, you'll be looking at vectors in two dimensions. So let's start off with the basics here and review a couple of concepts. So again, what is a vector? If you do not have the definition of a vector in your notes already, go ahead and write this down. It will also be helpful if you draw this image as well. So a vector is just a quantity with both magnitude, which is size, and direction. We can also use arrows, such as shown over here, to help us show both that magnitude or size and direction. So example, we have 10 miles per hour northeast or 5 centimeters south-southeast. We're also reviewing coordinate systems. The two that we talked about in week 1 are the cardinal system, which gives us north, south, east, and west, and the Cartesian system, which uses the y-axis and the x-axis. Remember, your x-axis goes from left to right or in the horizontal direction, and your y-axis, up and down, goes in the vertical direction. At the middle of this coordinate system, we have the origin, which is 0. And if we go to the right or up from 0, it is in the positive direction. And if we go left or down from 0, then it is in the negative direction. Let's also review the term displacement. Again, if you do not have this term, write it down. And this is a change in position in a frame of reference that describes the distance and direction of an object's final position from its initial position. We used displacement when we looked at average velocity in week 1. So for example, we can see these arrows here are not only showing us the magnitude, but also the direction in which, let's say, a person is traveling. This person may be traveling 10 meters to the right or in the positive direction. Stop, travel another 10 meters, stop, travel another 20 meters, then travel another 25 meters, and then travel another 35 meters. If we gave this an origin of 0 meters here, our question can ask us, how far did this person travel from its initial position? Okay, and we can do so because they're all traveling in the same direction here. We can add all of these numbers up, which will give us a total of 10 plus 10, which is 20, plus another 20, which is 40, plus another 25 gives us 65, and another 35 meters, which gives us a total of 100 meters. So the displacement here is 100 meters. Another term that we used in our average velocity lab was position. Again, position is a vector because it has both magnitude and direction. Okay, so from the origin in a frame of reference, we will use the letter X to symbolize position. We will also use this symbol, which looks like a triangle. This is the Greek letter delta, which means change in. So when we look at displacement, delta x is going to be a vector that represents a change in position. If you do not have this symbol, I would write it down. It will be a symbol that you will see often. When we look at vectors in one dimension, we can both add and subtract vectors. In one dimension, we are going to look at motion along a straight line. So whether that's along the x-axis or the y-axis. So in these examples, and we'll go over a few more. For example, we have the magnitude of this arrow A going in one direction and the magnitude of this arrow B going into the same direction. Because they're going into the same direction, we can add both of these, A and B, together to give us resultant C. Don't worry, we'll add some numbers here in just a minute. With vector subtraction, let's say that in this case, A is going into the positive direction, B is going in the negative direction. So we're going to flip this arrow around here. So A plus negative B is going to give us C, which is this much displacement. So let's actually look at some examples with numbers here. Let's say a car travels 5 kilometers east. So here is our magnitude, 5 kilometers, and our direction east. We'll also call that a positive 5 kilometers. This car is going to stop at a gas station, then travel another 10 kilometers to get to its final destination. We want to know what the displacement of this car is. So again, we can use arrows to represent both direction and magnitude. So if we have motion on the same plane, so this x-axis, right? So again, our Cartesian system here, we can see the origin is 0. And because it's going in the same direction, the positive direction, we can add them together. We can also, using the arrows, use a tip or head of the arrow to tail method, aligning these arrows together. So we have a positive 5 kilometers and a positive 10 kilometers, giving us here a positive 15 kilometers. So the displacement of this car is traveling 15 kilometers in the positive direction. So let's look at a different example here. Let's say that car now travels 10 kilometers east. The driver realizes that he's hungry and wants a burger from a restaurant that he had passed. So he turns that car around and drives 2 kilometers west. Because we're going in a different direction on that same plane, we're going to give that 2 kilometers west a -2 value. So again, using the tip to tail method, we align those arrows here. So we have a positive 10 kilometers plus a -2 kilometers. We want to know what this displacement is from the origin of 0. I apologize, it's not drawn a scale here, but if we add positive 10 minus -2 gives us a positive 8 kilometers. So the displacement is going to be positive 8 kilometers. Let's add more to that example. Now, let's say where we ended up at that burger joint, the driver realized he forgot his wallet at home and decides to drive back to his house, which was the origin. So I added another vector here in red, that -8 kilometers that he had to drive back to his house. So we had the positive 10 kilometers plus -2 kilometers plus -8 kilometers. Okay, his displacement was 0 because he ended up at home where he started. So those were a few examples. If you need any more help, go ahead and email your teachers. But you guys have a 5-question vectors in 1 dimension assignment. If you look in this folder, find the green puzzle piece that says vectors in 1 dimension, and that is your assignment for today.